Water, the essence of life. From the streams that carve our landscapes to the rivers that power entire cities, water sustains our world. But behind its life-giving flow lies a critical challenge: managing this vital resource responsibly.
The amount of water is finite in the world. It doesn't change. In the UK, the best water you can find is Manchester, Liverpool, and the best one is in Glasgow, actually.
In this documentary, we'll explore how the intricate systems of water and wastewater management are maintained, improved, and re-imaged by leading professionals in the field.
The water industry is heavily regulated. It has 3 regulators. You have the Environment Agency, and then you have the Drinking Water Inspectorate, and then you have Ofwat, which is the economic regulator.
Together, we'll explore the science, the technology, and the future of water waste management. From the software innovations driving efficiency to the global efforts in ensuring water sustains life for generations to come.
I think technology is enabling engineers and modelers to do far more now than what they were able to do before. I think what's really, really important is to remember that the software and the solutions are enablers. We still need that engineering knowledge to be able to drive these solutions.
Together, we'll explore the science, the technology, and the future of wastewater management. From the software innovations driving efficiency to the global efforts in ensuring water sustains life for generations to come.
First question I asked students when I used to go into class, when I used to teach, you said, when you wash your hands, water goes into a hole. Do you know where does it go? It goes to the ground, it goes in pipes, but very few people know it's a world behind that. So the amount of water is finite in the world. It doesn't change.
What a great comment. It never changes.
It never changes.
At all.
At all. It changes from one form to another.
Okay.
So it can be in the form of ice, it can be in the form of water vapor, it can be in the form of liquid underground. And what we have actually is about 2% of the available water is something we can utilize in the world. A lot of it is unreachable, or it's in ice forms in the north of the earth, but that 2% is what we can utilize. Now, this 2%, how much of it is available for us to use? And that's a question that very few people can answer. Is actually not a lot. I was a president of an institution here in the UK called Untitled Chapter, Institution of Water and Environmental Management, and part of my job was to go around to promote the institution and its activities. So I was giving a lecture on this very subject, and one of the audience objected. He said, well, you're giving us things about treatment, about conservation, about care, but if there is no water, what can we do? I said, well, that is not right, actually. Water is there, but polluted water is not good, because the damage that polluted water can do is more than non-existent, because it carries diseases, it carries viruses, it carries a lot of things. So the clever bit is, how can we utilize this water? How can we use this water and treat it? Not many people accept that you can treat sewage water so they can't drink it, but in fact it can.
Yeah.
There are ways in the treatment process where the water can become very pure and very drinkable.
Well, there is legislation. The legislation dates back to 1993, and it's EU legislation.
Yeah.
It's the Urban Wastewater Treatment Directive. And it's gone through the first round of review in over 30 years, but it doesn't necessarily apply to the UK anymore. Back when it was enacted in 1993, it created a step change in water quality. So things have actually improved, right, from where they were in the 90s, right? because that meant that everyone everywhere in Europe at the time had to have a certain level of water quality coming out the back of the treatment works. It set the baseline standards, right? So what's happened in Europe is they went back and they reviewed everything through the Water Framework Directive to have a look at what the health indicators on rivers were. And they found that things have just sort of leveled off. So the reason why they went back and reviewed it was to figure out, how do we get that next level of step change to occur? So the legislation that's going through right now, and I think it's going to be written into law at the end of the year for Europe and the EU, is the new revision that's going to include more stringent requirements for final effluent off the back of water treatment works, but also something called Integrated Urban Wastewater Management plans. And that's something where they want cities and towns to have a look at how they treat surface water or wastewater in general, which is surface water, which is the runoff, urban runoff, and also your sewage effluent. And the idea there is to have a look at the entire catchment and see what you can do to sort of improve the water quality of that river. And this is something that's going to come into effect probably in the next 3 to 5 years in Europe, where in any city with over 100,000 people. And then it's going to be a phased rollout. But that's what they're doing to try to kind of raise awareness around river health. Here, I think, given all of the media attention and the high profile fines that have come out, I mean, we're talking 126 million for Severn Water, 90 million for Thames. It's different. It's a different approach. We have regulated regime here where a lot of data is being put into the public domain. So you have citizen science now. You can go and look at your local area and you can see what's happening in terms of sewage effluent and sewage spills. It's actually publicly listed. But it's a little bit after the fact, you know? It's like it has already happened. I almost think that with the European legislation, they've had a look at what's happened here. Because on every single outfall, we now have what's called event duration monitoring. So it'll tell you how long a spill is occurring. And then you can go back and calculate the volume, right? But that's, again, it's happening. It happens. So I think what Europe is looking to do instead is create these integrated management plans to sort of prevent getting to that point.
As global populations rise and urban areas expand, water management has become one of the most urgent challenges of our time. By 2050, over 5 billion people could face water scarcity. At the same time, untreated wastewater contaminates rivers, oceans, and local communities, threatening both human and environmental health.
But added to sort of like the age of the infrastructure, we've also got the fact that with weather patterns are changing. So climate change is real. It's here. It's been spoken about on a daily basis now, and climate change brings about a number of issues for our drainage networks. So we're finding that those extreme flooding events, those low probability, high impact events, are happening more frequently than ever before.
It seems to be on the news every year now, whereas previously it might have been on the news once every few years or something like that.
Absolutely.
But it's devastating to see homes being ruined due to that, isn't it?
Yeah, and that brings about like so many impacts as well, those flooding events, whether it's sort of impacts on transportation or on buildings. You've got the impacts to the environment. You've got direct costs related to the operational cleanups and the infrastructure improvements. But you've also got the indirect costs as well, with loss of business productivity and having to rehome people, and you've got reduced property values in areas that keep getting flooded, and increased insurance premiums. So these flooding, those high impact flooding events bring about a number of challenges. And with climate change, those flooding events are happening more frequently. So I think between December last year and February this year, the Met Office said that there was 29% more rainfall than the long-term average, and there's particularly wetter sort of like eastern England and Scotland as well, where some areas received more than 1.5 times their average rainfall in one go. So what we're finding is that as the atmosphere is heating up, the atmosphere increases its capacity to hold moisture, which is leading to these more intense rainfall events. So all of a sudden, those drainage networks that we had underground, with a very limited capacity, is no longer fit for purpose. So we're having to find new ways to manage that water, and sustainable drainage is one of those ways that we can look to prevent water entering the network as quickly, and maybe we can look to sort of infiltrate or attenuate the water, reduce the runoff into the drainage networks.
In regions like Jordan, where water scarcity is a daily reality, managing water efficiently is not just a challenge, it's a necessity for survival. Professor Rafid Alkhaddar has been at the forefront of a project that aims to revolutionise water use in this arid region.
I was in Jordan about 25 years ago. And we had a project, a World Bank project for again, it's about educating on the water side as well. And you go there and you run and go the historical places. And there's a place which used to do what they called water harvesting. And you're talking 2,500 years ago. So that's not something new. We went into the desert called Jabur Desert. And you can see the remnants of rivers in the desert, where huge rocks are in the middle of that river when it was. And we asked and said, well, yeah, these were huge flooding when it used to rain. And the water was so strong that it carried all these. And you see, again, the remnants of lakes or underground lakes as well, reservoirs where they store the water. So that knowledge and that thing was there from the beginning.
Imagine going to a river, getting a bottle, filling it and drinking it. Can you do that?
You can, because if the water is running.
Yeah.
So it's not stagnated water.
So it's almost treating itself as it goes over the rocks?
Water will treat itself given the time.
Yeah.
So when we do a wastewater treatment plant, we are just accelerating the process.
Right.
If you leave water for a long enough time in the nature, it will treat itself. But it needs air, it needs movement, it needs mixing. And with these things, then it will treat itself. There's the oldest treatment method called an oxidation tank.
Okay.
An oxidation tank is basically a tank where the water comes in and goes out. And it's supposed to be, while it's coming in and out, by the movement, the mixing and everything, it will treat itself. The bacteria inside the water will actually feed on the organics in the water. So it will self-treat it. And by the end, that water should be safe enough to not drink, but at least to utilize for something. So for drinking, you might need to. But again, in the old days, there was no disinfection. Believe it or not, they used to. I went to a place called Petra in Jordan. I don't know if you heard about it.
Yeah.
And being a water engineer, you look for these things. So I was going to go to. Have you been to Petra?
No, I've never been.
It's a magical place.
Yeah.
So to get to Petra, you walk about a mile or so in between mountains, between the hills, and until you reach the village of Petra.
Yeah.
So when you walk, I noticed something interesting on the either side of the path. There were like ditches in the walls, in the sides. Some of them were covered.
Yeah.
Some of them were open. So when you look at them, you wonder obviously they're for collecting water. And every so distance in them, there is a hole in them. And then as we advanced to, and I went, there's a museum there, and I was there. Apparently the covered ones are for drinking water. So they collect it because In Bettool, when it rains, floods comes in and the water goes really 3-4 meters high and goes through these paths that we were in. So when it recedes, it goes into these small channels, let's call it, and they collect it. The covered ones are for drinking, the open ones for washing and everything else. And these holes, every now and then, is for sedimentation, they call. So if there is any particles in it, as the water slowly goes through, the particles will be caught into these ditches.
Almost like a sieve.
Like a sieve. And the water goes forward and it's collected. And in the museum, you see the old pipes there. So you look at the technology, that's 3,000-4,000 years ago again. So
incredible.
It is incredible when you see that. And being somebody who's obsessed with these sort of things, wherever I go, I picture these things and anything about water. You see that and you say, well, the knowledge is there. Is how you apply that knowledge, how you rekindle that knowledge and bring it back and look at it from this side. And then at least you understand where we're coming from and how we can use that. I mean, we have in Manchester huge amounts of rain. So we have no problem with the water. You go to the Gulf countries, they think they don't have enough water, but actually when it rains, it rains. But so what do you do with that water? It floods all your streets. It just goes to the sea, or it goes to the ground. So why can't we collect it and use it? Instead of the most expensive way of treating water is desalination plants they have. Gulf countries are the biggest in the world in desalination, and let's call the litre of water you use is much more expensive than a litre of fuel or petrol.
Historically, managing wastewater was often a reactive process, with limited understanding of its long-term impact on rivers and ecosystems. Early methods focused on basic filtration and rudimentary drainage systems, which, while groundbreaking at the time, fell short of preserving water quality. Today, technology is transforming the way we address these challenges, from advanced filtration systems to real-time monitoring of water quality. Innovative tools are helping us safeguard our rivers and ecosystems. By harnessing the power of data, automation, and sustainable design, we can reduce pollutants, optimize resource use, and create cleaner waterways for generations to come. Let's take a look into how these technologies are reshaping the future of water conservation.
Do you see technology helping in coming out with innovative ways to protect our rivers?
Well, the technology's here. It's just a matter of applying it. I mean, one of the things that they've always done in the water industry is they do know where their network goes, and they have a hydraulic model. So the hydraulic model is essentially like a replica of their network, except it's a model, and that allows you to run different simulations scenarios. So if you get a lot of rainfall, different types of storm, you can model that in and you can see what the impact would be on the flows in your network.
There are water digital twins out there. So digital twins is quite a large topic, and there's sort of multiple definitions of what a digital twin is. But in the water terms, do have a digital twin for the water industry. This is all around sort of being used for master planning.
And then it helps you predict where you might have sewer overflows. So in a sense, they already have the technology, and a lot of the water utilities here are using it, and they're using it to plan. They used to plan capacity because it'll give them an idea under what conditions they're going to have these problems. So there is that baseline level of knowledge. I think what needs to happen next is they need to move it more into real time. So that's what everyone's working on now. It's like, how can I give myself lead time to prevent the problem from happening? You don't want to wait until you get that EDM alert saying that you're having a sewage spill somewhere.
It's modelling your underground drainage networks. It's modelling the overground surface and the flow paths. and it's modelling the rivers as well, all within one integrated model to understand.
You want to have at least a day or more, to find out what you can do to prevent it from happening, whether that's reorganizing your storm tanks, changing some of your capacity around, or even, if it's surface water and flooding, alerting the people in that area. It's always about early warning. It's like getting an early warning system out. And that's the kind of thing that I see a lot of water utilities working towards now.
Can you tell us a bit more about, what we can do as individuals to prevent pollutants entering the rivers, or, what can we do to help out?
I guess as the public, to help out, I guess we have to be very careful about what we're putting down our drains. We have to. There's a lot of guidance out there around what you can and can't put down, sort of your sinks, toilets, sort of especially around things like wet wipes that block the systems. I think we have to be very careful around that and ensure that whatever we do put down is right. And I think we have to be very careful, like when we do go into the rivers. I think we need to be careful and maybe look online to see if there is any information locally around, what is the quality of the water at that point of time, especially after there has been a heavy rainfall event. So if there has been a heavy rainfall event, it's probably the times like those where there's likely to be more pollutants in the within our waterways.
If I could see anything happen, I almost think we need to reinvent sanitation in a way, I think. I mean, if you think about it, this is something, we're still using Victorian systems, right? What other industry do we still use a Victorian system like this? I mean, if you think about wastewater, and I do a lot, unfortunately, your toilet is being filled up with drinking water, right? That water is treated, it's abstracted with pumps and energy, and it's treated to a really high standard using chemicals, and then it's pumped all the way back to your house, right? And then what do? You flush it. I think 1/3 of all of the water consumption at the household level is just flushed. Now, why are we treating water to be drinkable and then doing that? And why are we doing that in the first place? It's almost like the whole system needs to be redesigned. I don't know how, but maybe the next generation will come up with something better, because that would possibly address two things. I mean, one of them is high water consumption. We're not actually consuming that water. We're using it to transport waste away from our homes. And then also, why are we putting the waste in water? I don't know. Originally it was to get it away as fast as possible. And now everyone wants to go swimming in rivers and seas and that are clean. So maybe we need to rethink the whole entire, what we call urban water cycle.
From the smallest streams to the vast oceans, water shapes our world. It sustains life, drives economies, and connects us all. But as we've seen, it's also a resource under immense pressure, a challenge we must all confront together. The solutions are within our reach: innovative technology, sustainable practices, and a shared commitment to protecting this vital resource. But it takes collective action, from policymakers and engineers to communities and individuals.
The amount of water is finite in the world. It doesn't change.
Water is more than just a resource, it's life itself. If we take care of it, it will take care of us.
A lot of data is being put into the public domain. So you have citizen science now. You can go and look at your local area and you can see what's happening.
The tools are there. It's up to us to use them wisely and build a sustainable future for generations to come.
I think what's really, really important is to remember that the software and the solutions are enablers. We still need that engineering knowledge to be able to drive these solutions.
It's not just about solving today's problems, it's about envisioning a better tomorrow. Our planet's future depends on how we manage its most precious resource. Together, we can rise to the challenge and ensure that every drop counts. What will you do to protect our water?